Hello everyone, in this video we'll learn how to delete an element from an array. Okay, we'll learn I will write the algorithm. I hope you can do the code in different language. So let us first consider a function. This is ARR is the array, key is the element to be deleted. Okay, and n is the maximum number of element in the array. So we have to write first the input. What the input part is? ARR is the array. I am writing in short, you can write in detail. Key is the element to be deleted, right? And n is number of element. Okay, n is number of element. I have written in short NOE. N is the number of element in the array. Okay, and output, what will be the output of this algorithm? Output will be key will be deleted. Okay, key will be deleted. Now in this algorithm, first I should tell you there are two parts. First we have to search this key where it is present in that array, where it is present. First part is searching. First we have to search the value key, then we have to delete. Okay, so let's start the algorithm steps. First step, declaring necessary variable, declaring I is for I am taking I for index. Okay, I, if anything else needed I will write it later. Okay, I it is of integer type, remember it. Declaring I equals to n. I first set the I to 0. Okay, first set I to 0. Well, let us consider an array. Let us consider this array. We want to delete this 7. Okay, we want to delete, what we want to delete? Delete 7. This is my key. Okay, 7 is the key, so I am pointing I here. Okay, now first we have to search. Okay, then running a loop while I less than n minus 1, while I less than n minus 1, sorry, for I less than n, it will run 0 1 2 3 4, it will run till 4. Okay, I less than n. Now this loop we are searching for key. If ARR of I equals to key, if the value is found, that means if 7 is found, then what we are doing, then LOC, we have to declare a variable LOC also. LOC setting the location as I. Okay, then break. Okay, breaking from the closest loop, that is breaking from the while loop. If not found, then what to do? I equals to I plus 1. Index, we will traverse the index. Okay, 6 7 8 step, we will traverse the index. Then here end of while, end of while. Okay, the ninth step is end of while here. Okay, now this portion is we are searching the element 7 to delete it. Now we will delete the element. Okay, I am writing it in this part. 10, while LOC, where is LOC now? We have searched and LOC is here. Okay, while LOC less than n minus 1. Okay, while LOC less than n minus 1, it will the loop will run till the third position. Okay, um, if you want to consider more element, it is fine. 5, 2, 3. Okay, it is fine. Yeah, the loop will run then from till 5. N minus n is 7. N is 7, minus 1 is 6 till 5. Okay, now step 11. What we are doing now, we have to delete. Here is LOC. Okay, carefully watch it. Here is LOC. We are doing ARR of LOC equals to ARR of LOC plus 1. We are just left shifting the element, left shifting all the elements towards LOC. Okay, then incrementing LOC. LOC equals to LOC plus 1. End of while. Okay, end of while 13 return, or you can write end of procedure. So what we are doing here, we are just left shifting the element. LOC is here, we want to delete 7. We are shifting the element like this, in this manner. Okay, why we are shifting? To delete it. In remember when I have uploaded the insertion video, I right shifted the element to vacant the location part, LOC part. Now I have to delete the location part, so I am left shifting the element. Okay, that's the difference. So this is the algorithm. So let's see how it's work. First, I equals to 0. 0 is here, and while I less than n, up to here it satisfies the condition. Enters is ARR of I is 5 equals to key is this. Okay, this is the algorithm part. Okay, key is 7. They satisfied? No. I equals to I plus 1. I comes here. Okay, let me take this here, you will understand it better. I is here first, then incremented. I here is 6. ARR of I is 6. Is 6 equals to 7? No. Then it will again increment I here. Now is ARR of I equals to 7? Yes. Now it is yes. LOC equals to 1. We are pointing this position at LOC. LOC equals to 3. Okay. Oh sorry. LOC equals to 2. That means LOC, then breaking from the loop, the end of while. Now the control will shift to this part. Okay, this step. While LOC less than n of I, n is here 7. N is 7. N of I is n of 1. N minus 1. N minus 1 equals to 6. 6 is LOC less than 6. Yes, see, correct. ARR of LOC, ARR of LOC, that means this position, it right shifted, means 10 will come here. Okay, consider this element to be not present here. LOC plus 1, LOC moves here. Okay, LOC moves here. Again they doing the same. 1 will travel here. Again doing the same, but LOC is here now. Now 2 will come here. Okay, 2 will come here. Okay, now again LOC incremented. LOC is here. See, now this will happen. Okay, 3 comes here. See, observe this. LOC don't move, go till the last index, not till the last, because last index is empty now. No need to go there. That's why we have written LOC less than n minus 1. Oh, I have forgot a thing. Before this return, you have to do n equals to n minus 1. I hope you know why I have done this. Because we are deleting one element. That's why number of element will be 1 less. So this is it. I hope you understood the logic part behind the algorithm. So this is it for today's video. Thank you for watching. And if you have liked my video, please share, subscribe, and Feel free to comment your problems and what video I should upload next. I will definitely try to do it. Thank you.